at point x naught with radius r greater than 0 in the set of all points in Rn whose distance from x naught is less than r. Thus, the idea of an open ball is to pave the way for the limits and how a function is approaching certain value. So the open ball idea is for each value in the space, if I have, or in R, if this is a point which is x naught, I can find an imaginary circle with radius r, where this is the neighborhood of this point. So this is what's called an open ball. So once more, an open ball centered at point x naught and symbolized by this form. When I read this slide, I will say that that's an open ball centered at x naught with radius r, such that because you already defined the open ball, but it can be defined on this form, that x belongs to Rn such that the norm of x minus x naught is less than r, which means the inside of this circle. So the open ball, it is the smallest circle that I can draw around certain point with r is equal to certain value greater than 0. It's a positive value greater than 0. Okay, that's the definition of an open ball. Okay, where x minus x naught, the Euclidean norm. What's the Euclidean norm? The x component to the power of 2, the y component to the power of 2, the z component to the power of 2 under the square root. That's the Euclidean norm. That's the representation of x, that is r, and that's the open ball. If I am in one dimension, it means the x-axis, for example, this is x naught, that is r, so this is gonna be x naught plus r, and on the other side it will be x naught minus r. That's the definition of the open ball. So actually the open ball in R1, it is the open interval which is x naught minus r and the x naught plus r in one dimension. But in 2 dimension, it will be represented by this circle. In 3 dimension, it will be a sphere around the point. So it's a sphere around the point with radius equal to epsilon, which is greater than 0. That's the definition of an open ball. Okay? معايا شباب؟ Okay, very good. So, once more, the geometric institution in R1 an open ball is an open interval, as I told you. In R2 it is the interior of a circle excluding the boundary. طبعا the open ball, it is all the points in the neighborhood of point x within the radius which is greater than 0, but not including the boundary of this circle. More generally in Rn it is the set, in R3 it's going to be a surface of a sphere. In Rn, طبعا we can't imagine the shape in Rn, but we call it a hypersphere. Because Rn is open, maybe R4, R5 or R6, you are not going to imagine if it is a sphere or something. You can't imagine it. معايا مش ده? Okay. What's that definition of open ball? How it is written in our main slides. Usually we can also symbolize it by this guy. So I can symbolize the open ball by writing B of an x naught and r, and also we can symbolize it by B epsilon at A, which means an open ball centered at A with radius equal to epsilon, or an open ball centered at x naught with radius equal to r. That's the definition of how to represent your open ball, either in the main slides, symbolization, or the given. If I am in 2 dimension, as I told you, we will be dealing with a circle, and that's the norm in this case. In 3 dimension, we will be talking about a sphere. طيب, what's the interior of a set? The interior of a set is all the points inside certain set without the boundary. So it is written A is completely contained in Rn. The interior of A denoted by int A, or sometimes a to the power of a circle is the set of all interior points of a certain set. So it is called the interior of A if there exists an open ball completely contained in A for some r greater than 0. This means you can draw a small bubble around X and still entirely within the set A. ده الديفينيشن بتاع الانترنال او الانترنال points relative to a set. All the points inside this set, you can draw circles around each one of them with r greater than 0, and they are completely contained in this set. That's an interior of a set. So it is this point with an open ball, that point with an open ball, this point with an open ball, open ball, open ball, open ball. All the points with their open balls are all contained in the interior of a set. So once more, interior of a set, excellence to n, such that there exists r greater than 0, such that all the points x with r is completely contained in A. So all the open balls for all the points are contained within inside A, not reaching the boundary. Okay, not including the points on the boundary. معايا يا فريق؟ Okay. ده الانتيريور اوف ا set خلاص عرفناه. طيب what's the exterior of a set؟ exterior of a set it is the complementary of the interior. يعني كل البوينتس اللي مش موجوده as interior تتصرف انها كايه؟ exterior. Okay, طيب what's the exterior؟ It is the collection of all open points that's completely contained in the complementary of your set. معايا؟ يعني كل النقط بالباوندري بتاعها. Once more, an exterior of A denoted by X A is the set of all points in R that are not in the closure of A. By the idea, كلمة closure we will define it. We will define it soon. The closure it means the interior of a set plus its boundary. يبقى كلمة closure it means the interior plus the boundary. External of a set, all the points without the closures. Okay, so it's not including the boundary also. AC it's Rn except A, so it is the complete space but without the interior part. Interior of AC, the interior of the A complementary, it is the exterior, it is the external of this relation. So what I want to say is the external of A equal to the internal of A complementary. Once more, this is A. If this is A, this is the set A, this set A. الاكستيريور كل اللي بره. فالاكستيريور اللي بره ده هو الانتيريور بتاع A complementary. لذلك exterior of A بيساوي الانتيريور بتاع ال A complementary. معايا يا شباب؟ Okay. Those definitions are confusing, and in multiple choices you really need to understand them very well, because if you have multiple choice they are really very close to each other. Okay, that's once more, that's the interior of point A, of set A, that's the interior of set A, that's the exterior of set A, and that's the boundary of set A. The exterior is all the points in the space without the closure. The closure is all this part, the boundary and the inside. Okay. It's once more it is defined. Also remark, the exterior of a set of A, it is can be defined also that it is the open balls with centered at A with epsilon that's completely contained in C complementary, which means it's in the external. صح؟ طيب خلي بالك, it is sufficient and necessary, يعني it will lead to in both direction, that the open balls intersection C is equal to phi. يعني هو الset of all points الانترسكشن بتاعهم مع الانترفال is equal to phi. There is no intersection between them, and it makes sense. All of these are equivalent to each other. What's the boundary? The boundary is the set of points. The boundary are the set of points that belong to both, that doesn't belong to both of them, to the interior or the exterior. ده boundary. شايف ده boundary. ما هوش related للانتيريور of a set ولا related للاكستيريور of a set. دي البوينتس اهي بتاعتي، دي الباوندري. لكن انت عارف ان الباوندري بلس الانتيريور ده الكلوجر زي ما هنشوفه كمان defined soon. So once more, the boundary is A dash intersection A dash complementary. A complementary which means the closure of A وده الكلوجر بتاع الكومبلمنتري بتاع A. يبقى الباوندري عيد تاني اللي انا قلته. What's interior of a set? The inside points, not including the boundary. What's the exterior? The out point, not including the boundary. خلي بالك انهم قريبين من بعض وبيلخبطوا. طيب الفرونتير اقدر اعرفه بكذا اسلوب، او الباوندري اقدر اعرفه بكذا اسلوب. من احد الاساليب ان الباوندري بوينتس دي، خلي بالك الباوندري بوينتس دي هي الكلوجر بتاع الاكستيريور. هو مين الكلوجر بتاع الاكستيريور؟ الاكستيريور زي الباوندري. انترسكشن الكلوجر بتاع الانتيريور. مين الكلوجر بتاع الانتيريور؟ انتيريور باوندري. يبقى هو فعلا باوندري بوينتس. ماشي؟ يبقى الديفينيشن ده برضو موجود معاك. The frontier are called the boundary. It is the set A denoted by alpha A or partial A. I'm sorry. It is the set of points where every open ball around the point intersects both A and its complementary. A bar is the closure of A. A bar C is the closure of the complement of A. As I told you, those are the boundary points. Remark that the open ball centered at A with epsilon intersection C is not phi, which means it intersects it. And with also intersecting the B complementary or the external of your set equal to C. Of course, the boundary of the set equal the boundary of the complementary. يعني the boundary of the interior of a set equal the boundary of the exterior of the set. They are both of them equal to each other. كلمة closure it is the adherence. كلمة closure it is the adherence. معايا يا شباب؟ الاثنين حاجة واحدة. What's the closure? Once more. The interior plus the boundary. Okay? The interior plus the boundary. يبقى the closure of A denoted by A bar is the set of all points A together with all of its limits point and it's called accumulation point. A plus the front union the frontier. Okay? And it is defined as you can see. It is the open ball at X with R intersection A and it's not equal to phi, so it is the points on the boundary. Every point in the closure is either in the set or arbitrary close to the set. This is important. The closure includes the boundary of the set. It is the smallest closed set containing A. It is the smallest set containing A. طبعا remark that these definitions are really confusing, especially in multiple choice. If he asks you about the closure and give you 5 or 4 statements and you will have to choose the right answer, you really need to focus in order not to make the wrong choice. This is the smallest closed set containing A as I told you. The closure or adherence of C is the interior plus the frontier. And also it is C plus the frontier of C. An open ball closed, what's the open and the closed sets? When to define an open set, when to define a closed set. C is said to be open if C enter the interior. And the C is said to be closed if C enter the closure. It's a closed set once the set is equal to its closure. يعني equal to its closure. يعني الانتيريور بلس the boundary. يعني ايه open الانتيريور without the boundary. Okay? That's it. And this is also very important to define if it is open or closed. ده summarization. ده open ball. This is the interior of a set. Okay, once more. ده exterior of a set. ده الانتيريور. ده الاكستيريور. طبعا ده الفرونتير اللي هو الباوندري اوف ا سيت والريليشن بتاعته. ده الكلوجر او الادهيرنس اللي هو ايه يونيون الفرونتير. دول الريليشنز انا حطيتهم في السلايد ده. You will find this slide in your PDF. Okay? I think I sent you this part. I will check after we finish if I sent it or not. Some properties about the relations. C is completely contained in R. Then an interior union and frontier union and exterior, that's the complete set. That's Rn. لو انا عندي set عملت الانتيريور union الباوندري union الاكستيريور, they will give you your set. Okay, interior of a set intersection frontier بيساوي phi. الانتيريور of a set intersection exterior بيساوي phi. frontier او الباوندري intersection exterior ده بيساوي phi. Let's see D belongs to Rn. Then C is closed and F and only F. C closed is open. Accumulation point, our isolated points, our driven points, those also are really very important. The accumulation points, it is the point at which you can find a limit. By the idea, sometimes the limit or the accumulation point doesn't belong to your set. And maybe your set contains a set of isolated points, as you will see. بص كده, A is said to be an accumulation point. F for every open ball centered on A contains at least one point of C except A. يبقى امتى اقدر اقول انها accumulation point؟ accumulation point دي لو انا عملت circle او عملت open ball, it will contain another point other than this point. تاني ندى تاني, لو انا بتكلم على accumulation point, what's the accumulation point؟ يبقى لو انا عندي point, accumulation point, it is the smallest circle, okay, that can within this point you can find another point other than this point, other than itself. معايا يا شباب؟ So once more, A is said to be an accumulation point of C if for every open ball centered on A it contains at least one. لازم تلاقي at least في إمكانية يبقى في point تانية. لذلك if I have a point within an interval, يعني from مثلا let's say from 0 to 1, half is an accumulation point. لأن around the half ده you can draw a circle with R أكبر من 0, صح؟ And you will find values within this radius. You will لو دوت 0.5 you can find 0.5213, 0.499995, which is very close values to 0.5. So 0.5 is an accumulation point. معايا؟ But if I'm talking about points similar than each other, زي مثلا زياد 1 2 3, اهو ال 2 دي ما اقدرش اقول عليها accumulation point. ال 1 ما اقدرش اقول عليها I can't say it's accumulation point. ليه؟ لأن ال 2 by itself هي 2 بس. فأنت لو حاولت تعمل circle حواليها أو بول حواليها with radius greater than 0, مفيش أصلا elements. فيبقى الانترسكشن الوحيد مع الست هي 2. معايا؟ في الحالة دي تبقى اسمها isolated point مش open ball. I'm sorry, مش accumulation point. معايا؟ تاني أوضحها. Let A is said to be an accumulation point of C if every open ball around A can contain another point other than A. A is said to be an isolated point of C if there exists an open ball on A whose intersection with C is just only A. مفيش حاجة تانية خلافة A. زي إيه مثلا؟ خليني أجيب المثال ده بس بسرعة. ده isolated point خلاص definition أنا قلته، بس خليني أتكلم على الاكزامبل ده. الاكزامبل ده حلو قوي، ده انا باجي عشان ده. بص على الاكزامبل ده. If I have A 1 with 2 and 3, so the set contains how many elements? 3 elements. طيب if those points are accumulation points, لا، لسبب. لأن for any of these points, لو ده my line with this is 1 2 and 3. If I try to draw an open ball around 2 with epsilon greater than 0, is it gonna cut anything else with 2 other than 2? يعني في points تانية هنا موجودة هنا الست دي؟ الست دي مين النمبرز اللي فيها؟ 1 و 2 و 3. بس هل 2.1 belongs to this set؟ هل 1.99 belongs to this set؟ يبقى I can't find any other point inside this circle other than mean 2. يبقى this interval, it is a set of isolated points. I don't have accumulation points. ما عنديش accumulation points بالنسبة للست اللي أنا بتكلم عليها. معايا يا شباب؟ كلهم isolated points. هودي لك مثال تاني بس إيه ورا ده على طول أو أشرح لك فيه فكرة accumulation points. This is just a finite set of 3 isolated points on the number line. So whatever you try to find an accumulation point, you can't. Because no matter how small an open interval or open ball you can take around any of these points, still the only intersection is this point by itself. So it's a set of isolated points. هنا A dash, which is the driven point or the accumulation point, is equal to 0. لكن يبقى كلهم isolated points. تعال بص على الانترفال على دي. This is 1 over n. 1 over n where n belongs to n capital. يعني دي تعتبر الست اللي شكلها عامل ازاي؟ 1 over 1, 1 over 2, 1 over 3, 1 over 4, 1 over 1000 صح؟ مجموعة النمبرز دي. النمبرز دي within an interval from 0 to 1. Am I right? From 0 to 1. كل السيريز دي هي مجموعة من النمبرز موجودة داخل 0 and 1 صح؟ طيب بص كده دول ست 1 half 1 third 1 4. لو انت جيت تبص على دول هتلاقي فيها accumulation point. في بوينت دي accumulate around زي مثلا الزيرو. هتلاقي ان لو انا جيت عند بوينت 0 وحاولت ارسم اوبن بول هتلاقي حوالين الاوبن بول دي في هاف في 1 third في صح؟ في elements belongs to this set. يبقى اذا الزيرو is an accumulation point. But those points by themselves they are isolated points. لذلك تاني once more. The point 0 is not in the set. يعني الصفر مش belongs to this set. بس it's a combination point. Okay? But the values of all of them get closer to 0. So you can find a circle or an open ball around 0 where you will find elements other than 0 belongs to this set. Okay. The isolated point 1 over n, all of them are isolated points. لأن 1 over 2 I can draw an open ball with epsilon greater than 0 with just only 1 over 2 as the element, away from each other element around 1 over 2. So the isolated point is A itself. A derived set هي كل accumulation points. الست دي فيها accumulation point واحد which is 0. يبقى derived set بيساوي 0. This is where you strengthen your idea about the problems in this part. I want you to indicate the interior, the exterior, the adherence, which is the closure, the derivative, which is the boundary, the isolated points, or the derivative, the accumulation points, and the driven points. 4. بص كده ندى 1 minus x square minus y square greater than 0. لو انا ببص على 1 minus x square minus y square greater than 0, which means 1 greater than x square plus y square. يعني معناها x square plus y square less than 1, which means a unit circle, the unit circle with all the elements inside the circle. يبقى أول واحدة ده هي البوينتس inside the circle. طيب دي اللي هي y minus x square greater than or equal to 0. It's a graph for a parabola. بصوا كده y minus x square is greater than or equal to 0. يعني y is greater than or equal to x square, which means this is a second degree parabola. That's a parabola. Okay? With where the points of my set are all the points inside the parabola, not outside the parabola. بس خلي بالك ان انا عايز ده and ده union the units or the elements of 1 over n including 0. يعني 0 1 1 over 2 1 over 3 1 over 4 1 over 5 1 over 6 and so on from this from this part where n belongs to in capital. يبقى إذا all these points also are included. If I want to get the intersection of all of this, أنا عايز البوينتس inside the unit circle والبوينتس inside the parabola، يبقى أنا هروح أرسم اليونت سيركل، أدي اليونت سيركل بتاعتي، يبقى ده الجزء اللي أنا بتكلم عليه. This is how to get the region. يبقى الريجن بتاعتي جزء من سيركل وجزء inside the parabola معايا، بالإضافة للبوينتس اللي هي 0 وهاف 1 over 3 1 over 4 مجموعة البوينتس اللي موجودة طبعا. اهو دي السيركل لان مفيش فيها ايكوال ساين، ده البارابولا لان فيه ايكوال ساين، دي البوينت بتاعت الزيرو بلس البوينتس اللي هي 1 over n. I will add them اهو a sequence of isolated points along the x-axis 1 over n والy بتاعها بيساوي 0. الانتيريور هيبقى x سكوير بلس y سكوير less than 1 and y greater than x سكوير. طبعا دي محلولة عندك، الاكستيريور هو ايه، الباوندري هو ايه، ازاي ريبريزنتد اند سو اون، فخليني مش هضيع فيه وقت، هو موجود ومحلول عندك وانا فرده، حتى كمان استعنت بيه يعني علشان اكتبه بسرعه استعنت بيه شات جي بي تي اعتقد. هنا بيقول limited sets in R. D is said to be bounded if there exists a number R greater than 0 such that D belongs to the open ball at 0 with radius is equal to R. كل اللي انا قلته بقى من الاول لغايه دلوقتي، بس خليني اشرب بق ميه خفيف كده. خلاص مش ده اصول يعني. كل اللي انا قلته مش سلاي، all the definition that we took in order to pave the way for the definition of a limit in the case of several variables. What's the definition of a limit? The definition of a limit in single valued function is when x changes, the y will approach a certain value. So while x changes to reach certain value, the value of the function will change to reach or to approach a considerable amount or an output from your function. When the limit is going to exist, if the left limit equal to the right limit, or the function from the left equal to the function from the right. That's the definition of the limit in one dimension. But the problem with two dimension, starting from two dimension, and it will increase it in dimension of course, but starting from two dimension, you can approach from plenty of buses, not just only from one bus. Okay, let's look to this function. I have limit of f of x, which means y for a function y equal to f of x. I am searching for the value of f of x when x approaching x naught, which is gonna equal to L. And same way if I'm coming from the other direction, which is gonna equal to L. So I'm saying that this is the x value, and this is x naught, this is x naught plus, those are the values approaching from the right, and negative, those are the values approaching from the left. Once they are coming together, the value of the function is reaching a certain value, which is M. In this case, that's the definition of the limit. صح? Okay. Also, it will appear to you on this example. Look to this example. I have f of x. When x is less than 1, it's 2x plus 1. When x is greater than or equal to 1, it's equal to x squared. Let's see if this limit exists or not exists. Ya Faisal, if I'm taking the limit of f of x, if I'm evaluating the limit of f of x, where x tends to 1 negative, what's going to be the function from 1 negative? The function in 1 negative, it's going to be the case of x less than 0. So it's going to be 2x plus 1. Once you make a substitution, the result is 3. Let's get the value of the limit from the other direction. Okay, you will have limit x tends to 1 positive. So I will use the other branch, which is gonna be of an x squared and it's equal to 1. Since these two values are not equal to each other, then the limit of this function doesn't exist at x equal to 1. صح? But this is really very simple, Ziyad, in the case if I'm talking about a function in one variable. Because actually x is just changing and y is changing in front of it. But if I'm talking about a point in the plan, this point, you can approach this point in the plan from plenty of passes, actually infinite number of passes. You understand what I'm saying? On the x direction, you can approach from the left or from the right. There is no other way. But in the plan, which means in 2 dimension, you can approach a point from plenty of ways, according to plenty of curves. Can you imagine if I'm talking about a point in space, how to approach this point? Can we approach from the right, from the left, from the inclined way? Infinite number of curves. So this is the problem with studying limits in several variables, that you can approach the limit from any other direction. So once more, this is the limit negative, limit positive. They are not equal to each other from the two sides. It's not equal. The problem, as I told you, if you try to approach a certain limit, but in 2 dimension, it's going to be the limit of xy approaching the certain point A and B. There is no one curve. There are plenty of curves in order to approach the point A and B. Plenty of curves. And so for them to equal to L, for f of xy equal to L, all of these values must equal to each other. So once more, the limit of f of xy as xy tends to AB is written in this form. At the point xy gets arbitrarily close to AB, the function value get arbitrarily close to L. Unlike functions of one variable, this is what I'm trying to explain to you. Okay? Unlike functions of one variable, where you approach from left to right, in 2 variables, you can approach AB from infinitely many passes. Passes clear again. Along lines, parabolas, curves, spirals, etc. For the limit to exist, all of them, they must equal to each other. If you have all of them equal to each other and just only 2 passes not equal to each other, the limit doesn't exist. Okay? This is in 2 dimension or in dimension. Continue. يعني for example, بص كده معايا. I have f of xy equal x squared plus y squared. I want to get the limit of this function where xy tends to the 0, 0. If you make a substitution, خلي بالك، يعني ده معناه ان انا عندي البوينت circle وهي كلها بتحاول from any direction using any function try to approach the origin. If xy equal to 0, 0, the value of this function will equal to 0 from any direction. This is why the limit of x squared plus y squared when xy tends to the origin is equal to 0. Because from any direction you can use, the value result will be 0. Okay, let's try. If I want to make or to reach the value of the function using x equal to 0 around the x-axis, oh, I'm trying. Around y بيساوي x, around y equal to 0, around y بيساوي sin x, all of them will be equal to 0. بصوا كده. مهم قوي انك تفهم دي، هتفرق معاك كتير. ده الاكس اكسس، ده الواي اكسس. This is the point 0 and 0. I can approach this point in the 2 dimension through the x axis, through the y axis, through y بيساوي x, through y equal to negative x squared, through y equal to sine of x. All of them will approach this value at 0. This is what I mean. I can approach the origin using infinite number of curves. Okay? And all of them, the limit will be 0. So the limit existence equal to 0. This is not going to be the case in other problems, as you will see. Okay, so if I tried any of those functions, the limit will be 0. Let's try this guy. xy over x squared plus y squared. Miss Seda, let's try the y-axis. What's the equation of the y-axis? So I'm trying to get the limit of x, y tends to the origin, but through this guy. So I will have to replace x was equal to 0, so it's going to be 0 times y, and 0 plus y squared. The result will be, because here you are using the value of the function before the limit. This is the logical order. Okay? So if you are trying to approach the origin using the y-axis, the result will be 0. Now let's try to do it using the x-axis. The x-axis y will equal to 0. صح؟ يلا. يبقى limit x, y tends to the origin. يبقى أنا عندي y, x 0 and the x squared plus 0. The result will be, you have two passes and the both of them is equal to 0. طيب, let's try y equal to x. This is going to be limit x, y approaching the origin. For x dot, I will replace y by x. It's going to be x divided by x squared plus x squared, which is simply going to equal to 2 half. Is it the same result? So the limit of this function doesn't exist. معايا؟ فاهمين قصدي ايه؟ For this function to exist, it must be like this guy. Approaching using any function whatsoever, the result will be the same. ماشي? The statement is written, you will see it right now. So